Welcome to Surfx Technologies here at Semicon West. I'm delighted to be joined by Alan Vucetich. Good to see you, Alan.
Good to see you, Trevor.
Okay, so you've got a fairly unique proposition. You're one of the, I think, first companies to do inline atmospheric plasma for microelectronics. Tell us a bit about your proposition and how you're different from other plasma companies.
Yeah, well, we're definitely not the first to do inline plasma, but we're the first to do it with Argon.
Right.
So there's a lot of different ways to create plasma. Some of it's in vacuum, some of it's in atmosphere. Some of it uses inert gases. Sometimes you use clean, dry air. Okay. We've had a massive breakthrough in about 2018, 4 or 5 years ago, where we were able to create atmospheric plasma using Argon.
Okay.
Prior to that, it was helium.
Yeah.
And helium, as you know, is in dwindling supply, and it's becoming very, very expensive, and sometimes you can't even get it unless you have the right priority access to it, such as medical processes. Argon, on the other hand, is ample. It's you can ship it in liquid form, so you can get a lot of it, and it's cheaper, and it's just a lot more practical.
Right.
And that has allowed us to, among other things, branch off into many high-volume areas and industries, including microelectronics, semiconductor packaging, and really make an impact where we couldn't before that.
Okay. Now, I see as part of your presentation, you've tied up with Mycronix AXXON.
Yeah.
That's obviously helping you to deliver some of these high-volume automation systems. Tell us what that how that operation works.
Yeah. So that's the other piece of the puzzle, along with the Argon plasma. About 2 or 3 years ago, Mycronix made an investment in Surfx Technologies. They believed in us enough to actually partner up with us. And that allowed us to go from a benchtop style robot that we'd have to integrate or engineer ourselves on manufacturing lines to now leaning on them and partnering with them to use their automation, their turnkey systems, where we can meet industrial demands and commercial demands in ways we couldn't before.
Right.
And it's been a tremendous partnership. It's been extremely valuable to us, and we're already seeing a lot of the that partnership come to fruition.
Right.
So to say with that.
Okay, great. So let's tell us a little bit about the process itself. I mean, you're doing obviously flux removal and being able to stop oxidization of the parts. So talk us a little bit through how that works.
So you can get really technical. There are entire courses taught on plasma. So I'll try not to put everyone to sleep. As I said, there's a couple of different ways to create plasma. Some of it's in vacuum, some of it's in atmosphere. When you use clean, dry air to create plasma, you need a lot of power. So you need like 20,000 volts to ionize clean, dry air. Plasma is an ionized gas.
Right.
When you do that, that clean, dry air is going to collapse into an arc very quickly because the ionization rate is just flying up. It's an exponential rate. On the other hand, if you have vacuum, you can create something called a weakly ionized plasma, where you can control the plasma and it's not going to arc, it's not going to run away. That's in a vacuum, though. In a vacuum, you use an inert gas to create that. That can be a lot better because it can be safer in certain ways for substrates or for the operator. You can imagine if you have a 20,000 volt clean, dry air plasma, well, that can be a little bit dangerous depending on the process that you're using it for. What makes us unique is that we can use those inert gases that vacuum plasmas use, but we can create plasma in the atmosphere. And that gives us a ton of different benefits. We can treat parts without damaging them at all, so we don't have any etching or we don't change the integrity of a surface when we treat it.
And you do it at low temperature as well, is that right?
With temperature?
You're doing it at low temperature?
Oh, at low temperature, correct. Yeah, so there's very little heating of our parts, so we can treat things like wafers, electrical components, boards, biomedical devices that go in your body. Things that if you mess with the integrity of that surface, you could lose the conductivity, you could use the usability of it, and if a pacemaker breaks or that bond isn't good, that could be a real problem for a lot of people. Similar to your phone, when you're putting things together, when you're bonding two components, if there's any contamination between those two layers, that's going to interfere with the bond and the strength of the bond. And so what we can do is we can treat those components that are sensitive, clean them, activate them for that bonding process, and not cause any issue.
Excellent. Okay, so finally, I want to look at the different types of products you've got. You've got a benchtop model here, which I think customers who are not sure about the process or whether it will be right for them can take that as, I believe, to to test it, as it were, and see if it works for them. And then if it does, then of course they can move up to the inline systems or whatever size or capacity they need.
Yeah, absolutely. So it's a big challenge to get someone to invest money in a commercial or an industrial process. You have to find space on the line, you have to work with all the engineers, and there's a CapEx involved as well. So we do have tabletop or desktop sized machines. The technology is the same. It doesn't matter whether it's a desktop machine or one of these high volume machines that can do multiple dozens of thousands of units per hour. The technology is all the same. So we let people rent the machines, or we can actually bring them to client sites with us to treat parts. And the rental obviously is much cheaper for a short time, and usually the on-site demos are complimentary. So that gives us a really flexible applications process when we're testing applications, because people can send us coupons, we can go to them. If they have a secretive process, they don't want, maybe they're one of these high-tech companies, they just want to test it themselves, we can give it to them for months or 3 months, whatever they want. And we also give people credit for rentals as well towards a purchase. So
well, that's a great idea, actually. So So it sounds a really interesting system, Alan. So I want to thank you for certainly for telling us about it today. And I'm sure as we get to know you better, we'll dig in a bit deeper to learn a bit more about it.
Absolutely. Thank you so much, Trevor.
Thank you.